That's not
live.
And I think some of you, when you see your paper, you're going to be like, what was I thinking?
That day.
All right. All right. So we're in 1.1 or 2.1, I mean 2.1, and we are looking at problem number 4, and we're going to talk about correlation. Now, we have plotted, taken data before and found a parabola that fit the data or a line that fit the data. Associated with, if you have some data points, draw a line through them, associated with that line is called a correlation coefficient. And that coefficient can tell you how truly linear the data is. Now you can kind of eyeball it too, but this is more of a mathematical way of telling how truly well your line fits the data. The correlation coefficient is R, and R, they use R as the letter, regression, I think that's what it stands for. And then it ranges from -1 to 1. Okay? The closer you are to 1, the more positively correlated your data is. The closer you are to -1, the more negatively correlated your data is. The closer you are to 0, the less correlated you are. Okay? Now, what's a positive correlation? Well, if you're plotting data points at X and a Y, then those two things are either going to go up together, or one is going to go up and the other one's going to go down. So if they are moving in the same direction, then you have positive correlation. In other words, the slope of your line is positive. If they're moving in opposite directions, then your slope's going to be negative and you're going to have negative correlation. So all that is kind of outlined in number 4. Okay? Now, let's see how this works. So let's go to number 5. Let's go to Stat, Edit, and let's put in the data for problem 5. All right, so 240, 260. So everybody's putting in their data.
Stat edit.
That's 1. Yeah.
These are big numbers. All right, everybody got them in? Who am I missing back there? I'm missing a couple people. And Oliver. All right, you got it in? All right, so let's go back to Stat then, and let's do a linear regression on it. So Stat Calc, linear regression. My equation came out to be this.
Oh, the down calculator.
So did anybody else get a line that looks like this? Now, did your R value pop up
No.
when you did that? Okay, I was afraid of that. So okay, did anybody get an R value to pop up? Like do the new calculators just come up automatically?
My equation doesn't look like
Okay, let's check your data points.
Well, mine just, it doesn't write it out for you, but it gives you y equals ax.
Well, yeah, mine doesn't write it out either, but yeah, I can write it out. All right, now, to turn your R value on, I know there's a way to do it quicker, but I can't remember what it is. So find your catalog, it's right down here. Go to catalog. And then go down to the D's, and where it says diagnostics, make sure diagnostics are turned on. So you want the diagnostics turned on. And now go back and do your linear regression and see if it gives you an R value now. Did anybody get an R value now?
Yes.
So R is negative 0.98. Yeah. If our R value is negative 0.98, what does that tell me about my data? Very strong negative correlation. The slope is negative, and the points fall very close to that line.
Oh wait, I still don't get an R value.
okay, go back to that. I don't know what C is.
All right.
Oh, are you you just hit the one where it's just AX plus B.
All right, let's try one more.
There's like a bunch of different.
All right, whoops. All right, let's try the next one. So let's try again, help each other. I'm not getting this.
Is it R? I don't know.
We're going to edit. We're clearing out the old.
Why does it give me R squared?
There are a lot of statistical things that your calculator will do. We're just looking at R. Sort of like variance and standard deviation.
Oh, I think I would. No, I thought, no, I like.
All right, after you get the data in, go ahead and do a linear regression on it.
Are we doing 6 on that one?
Yeah, we're on number 6 now.
Oh, you're on the next one. Oh, you're still figuring out
I'm doing random rounding off, but that's what I got. And this time, my R value was like 0.95.
How do you know what were you at?
Go to catalog. Down by 0, it says catalog. Go to diagnostics on and hit enter. And then go back and do your regression again. By the way, if you didn't know about that catalog button, anytime I can't find something, that's where I go. Because that has everything in it. everything your calculator will do is leave that on. So I know there's an easier way to get to diagnostics on, I just can't remember what it is. I turned mine on and it's just always on, so I don't have to do that very often.
So once I got rid of that, once you're at the, you put in all the numbers, what do you do?
Exit out,
Okay.
go to stat, over to calc, and down to linear regression.
Linear regression. With the A plus BX or just A? Just regular linear.
Linear regression, hit enter.
Okay.
And it should give you this equation. Now, tell me about this correlation. I got about 0.95, I think it was.
Yeah.
So that's a very strong, positive correlation. Now, stop and think about what this problem's about. What were the data points you were putting in? Age and weight of babies, right? Or little kids. Does it make sense those would be positively correlated?
Yeah.
The older the kid gets, the more he weighs, right? Right. So that makes perfectly good sense. Now, we did not draw a scatter plot. Let's go ahead and do that just to review how to do it. So what we do, all your data is already in, right? But I do need to set my window to accommodate the data. So, I'm doing a scatter plot. I'm reviewing that with you, not going back over it. Just put your hand down and listen. Now, we're going to window, and we're gonna set our X's to accommodate our X's. So maybe 15 to 50. Nothing sacred about those numbers, but somehow I gotta include all my X's. And then my Y's, maybe 20 to 50. That'll take care of all of them. Now, I gotta turn my plot on. It won't plot points unless I turn my plot on. So I'm right up here, that's my Y equals button, stat plot. So I'm gonna turn that on, so plot 1, turn it on, and then hit graph, and it will plot those points for me. They're not a perfect line, but are they moving in a linear way? They're certainly not like this, right? They're moving in a linear way, positive slope, that's your scatter plot. Now, caution, you might want to turn that plot off right now, because when you try to graph later, you'll get an error, and you'll say, why am I getting an error? Because your plot's on, and a lot of times your calculator won't graph when the plot is on. All right. All right, put the calculators away for a minute now. So if you found a pile of data out in the hallway and your correlation coefficient was 0.2, R was 0.2, what could you conclude about that data? Very, very weak positive correlation. So when you graph those points, they wouldn't be as nice and linear as the ones we just looked at, right? There would be sort of a linear shape to it, but it would be very, very weak. All right, write the equation. Now I'm on number 10. We did some of that the other day. So I think we're ready for 10. Write the equation of the quadratic function whose vertex is this and f of 1 is 5. Okay. Write the equation of the quadratic function. What's that mean? Write the equation of the parabola? Quadratic function?
Yeah.
And I know, because I've spent a whole chapter graphing things like this, totally made up. But isn't that a parabola?
Yeah.
And it's a parabola whose vertex is -1, -8, because it's moved 1 to the left and down 8. So if I know this is the vertex, they told me in the problem, that's the vertex, can I at least do this part of the problem? Would you agree with that? Now, how many parabolas in the world are there with that vertex? Yeah, I would say a lot. Yeah, like billions and trillions and zillions. What makes them different from each other? All these parabolas that have the same vertex, what makes them different? Whatever the stretch is, right? And the direction, because that could be negative. So basically what you're telling me is, there's a lot of parabolas that have this going. I need to find this special number out here in front, call it A, N, J, I don't know what you call it. That's the number we're missing, right? To tell us exactly which parabola we want. Now, we don't know anything else about this parabola except the point 1, 5 is on it. Remember, this is a quadratic function. I was using y, but I could have used f of x. And apparently when I plug in 1, it all equals 5. Well, shoot. Can I figure out what n is then? Because if I put a 1 in here, it has to end up equaling 5? So 1 plus 1 squared is 4. Please don't subtract these, this is 4n. So 8 equals 4n, and n is, and there's the equation of your quadratic function. So, this is the vertex, so this got me started, right? Then they gave me some random point on the parabola. Now they wrote it in function notation, but remember, f of x, that's your x right there, and that's your y, so that's just a point. When I plugged it into my equation, then I was able to figure out what this magic number is out in front that controls how I open and how fat I am. You've seen this before. It looks different this time, but not really. Because what's G stand for? It says there in the problem, what's G stand for?
Gravity.
Acceleration due to gravity. And what does it equal in feet per second? It is 32. So what happens if I put 32 in there? What does this equation look like? Doesn't it look exactly like it looked before when we did it? Now, note that if your velocities are measured in meters, if your distances are measured in meters, then this isn't 32, then it is 9.8. So you gotta pay attention to what's going on.
Is it?
All right. Yeah. Who can throw a baseball the highest from the front row of the upper deck of seats, which is 83 feet above field level? The winner throws the ball with an initial velocity of 92 feet per second, and it lands on the infield grass. Find the maximum height of the baseball. Well, What shape is this? Parabola, opening down. So don't I just want to know the vertex? Alright, so let's build the equation from the information they give us. You can call this y if you prefer. That part doesn't change. Did you notice that everything's in feet? So that's why I'm using the 32 or the 16 one. Alright, so what do I do about the initial velocity? This guy right here. 92. And what do I do about the initial height? 83. Now, if I actually drew this picture on the coordinate axis system, it actually looks like this, right? Because the guy started up here. And eventually it's gonna come down into the ground, okay? I wanna know its maximum height. So, can I find the vertex of this? What's a quick, easy way to do that? So for the axis of symmetry, so x equals negative b over 2a. That probably isn't anything nice. Oh, it's not bad. 2.875. Now, what does that number stand for? That's your x, which is your t, which is your time. So if it said, I know there's lots of questions there, if it said, how long does it take the ball to reach its highest point? Then you would say 2.875 seconds. But that isn't what it says. It says, how high does it go? So what are we gonna have to do? Plug that into here. So, negative 16 times 2.875 squared plus 92 times 2.875 plus 83. I got 215.25 feet. Did I type it in right? Test?
We're using the negative 16 squared.
Huh?
We're using the negative 16 t squared equation, not the negative 1/2 t squared.
Well, g is 32. What's negative 1/2 times 32? Right? Alright, so we good with that? So the question was, find the maximum height of the ball, 2.15, or 215.25 feet. Easy. How much time is the ball in the air? How much time is the ball in the air? What do you think, Lewis?
When you plug 0 in for S of t.
Oh, Lewis says, I need to know what this is right here. Because won't that x coordinate be how long the ball's in the air? And in order to do that, I have to let y be 0. So I need to solve that equation. How will I do that?
Wouldn't you just
Well, I'm not gonna rule out factoring. I'm gonna say I'm not gonna try. Cause it's quadratic, it might factor. What else can I do if I don't wanna try to factor? Yeah. So I got a calculator. So t equals negative 92. 92 squared minus 4a c all over 2. You're gonna get two answers here, and one of them is gonna be negative, and we're gonna have to throw that one out. 7, 9, so that one's out, I don't want that one. Should've thought about it before I typed it in, but I got 6.54. Anybody else get 6.54? Tess?
I'm confused why you divided 92 by 32.
Wait. What's the axis of symmetry formula?
Oh, 92 over 2. Oh.
Right?
So for this, like trying to find t, would be like you're trying to find t when x equals 0, or no, sorry, when y equals 0.
Yep.
So okay.
So I got 6.54. Anybody else get that? So how long is the ball in the air? 6.54 seconds. Yep. Determine its vertical velocity when it hits the ground. Now, this is new, but you're given what you need. In the, up there with all the information, it says V of t is negative gt plus v sub naught. Now, v sub naught is the initial velocity of the object, which was 92. What's g? They tell you in the problem, what's g? 32. And when the ball hits the ground, the time is 6.54. This says find the velocity when the ball hits the ground. So we already figured out that the ball hits the ground at 6.54. This little formula gives us the velocity at time t. So, let's see what it is.
What's the t value again?
Right here, the one we just found, when the ball hits the ground. I got negative 117.28. And that would be feet per second. Does that make sense?
Yeah.
Why?
Going down.
Going down. Velocity is directional. Speed is not. Speed is just not a scalar, just a number. But velocity is directional. If you're going down or going left, your velocity is negative. So that is the same as 117 miles, or not miles an hour, 117 feet per second. It's just you're going down instead of up. A negative velocity means you're going down in terms of the vertical. As before, if I need you to use these formulas, I'll give them to you. All right, one more. Using algebra in landscape design. All right, here we go. Julie's got a patio that's 25 by 40. Patio is surrounded by a terraced strip of uniform width. So kind of like a picture inside a frame, only it's a patio inside of whatever. The area of the strip is 504. Find the width of the strip. All right, does the picture make sense to you? All right, so let's see if we can come up with what's officially called a mathematical model. We call it an equation. Can we come up with an equation for this? What would that equation look like? All right?
Okay, so I would do the idea I'm going on is to do the area of the whole picture minus the Tara's strip, and then wait, actually,
No, we can do that.
okay. Well, I
So
was
the
gonna say
whole minus the strip, the shaded part, would equal what? What would
the
that have to
area of
equal?
the inside.
The picture, the area, or not the picture, I'm thinking frame, the area of the patio,
Yeah. But
that'll work. I
just
mean,
don't-
you can do it other ways too,
Oh,
but
yeah,
that
okay.
will work.
and I was gonna say I would do 25 plus 2x.
So if we're doing the whole shebang, she says this is 25 plus 2x. X up here, X down here. And then that is
40 plus 2.
40 plus 2x. So your whole thing is 25 plus 2x, 40 plus 2x. We know the strip is 504, and we know the patio is 25 by 40, so what is that? Is that 1,000?
Yeah. Yeah.
So you could set up this equation different ways, but she's got it, that's right, that'll work, right? So how should we solve this now?
Well,
Yeah, probably gotta get it foiled out, so we got 1,000 plus 50x plus 80x plus 4x squared minus 504, 1,000. So 4x squared plus 130x minus 504 equals 0, double check that. I think that's right, is that right? It's quadratic equation, be careful. Am I looking for a maximum?
no.
Aren't I just solving that equation?
Yeah.
Gotta keep it straight. If you're looking for a maximum, you're gonna do negative b over 2a. If you're just solving it, you're going to probably use the quadratic formula. Now, this one is divisible by 2, which feel free to do that if you want, but since I'm using my calculator anyway. Oh, wow. I got 3.5 for one of the answers. Oh. That's the only one. Won't the other one be negative? I don't want that. So did you get 3.5? And that unit is feet, and that's x, the width of the strip, so I am finished with that. Okay? What homework will we do on Wednesday? Remember, you can come to